So guys, here's the scoop, and I know that you don't know the difference because we're just getting used to working together. But guys, I owe you apologies all over the place. So let me get started. First of all, guys, you took a test back on the 14th. Today's the 26th. That was almost 2 weeks ago. Some of you can't even remember taking that test, and you haven't got them back yet. And guys, this is absolutely my fault. It's inexcusable. It's not okay. So I'm not trying to explain this away. What I am trying to do is help you understand why it's been 2 weeks and you haven't seen your test yet. And guys, the answer is this. Up until this year, we've allowed people to do retests, which simply meant if you missed the first test, I could hand them back the next class period, which is typically what I do. And then for those people that didn't take it, they just take the retest, and I can get you immediate feedback on your test, which is best. The problem is if we're not doing retests, then I've got to wait until everybody's done with the test before I can hand them back. So now you're thinking, well, why don't you just post our scores? And to be honest with you guys, the reason that I don't just post scores is because I want to be present when you see your scores so that if you have questions, you can get them answered, because I find that the minute you get that test back, you read through it, and you're like, hey, I'm not sure about this. If I just post the scores, you see your scores, then a week later when you get your test back, you sort of miss that opportunity. It's not as pressing in your mind, and people tend to not ask questions. With that said, we still have some people that have not yet taken the test. So guys, I'm not going to hand the test back to you today. The reason I'm not handing the test back to you today is not because I'm trying to make space for those people that haven't taken the test, because they totally screwed up. The reason that I'm not handing the test back to you today is because we don't have time. We're going to have a ton of time on Wednesday, so I will give you your test back on Wednesday, and that'll work great. Okay, then the next thing I need to apologize to you about is actually the investigation project that you guys did. Remember, you shot the videos, you made a homework assignment, and you did an answer key. And guys, this is blowing up in our face. It turns out that our district has so completely separated your Google Drive from my Google Drive that I cannot see your videos. And I can't see your homework assignments. I click on these links and it simply says cannot access. So there were a few of you that actually posted your videos not from your Alpine SD account, but posted them from your personal Gmail accounts. And I could watch those. And frankly, they were awesome. I really enjoyed watching them. But guys, I've been talking with our computer people, and they do not know when this is going to be fixed. So I'm just going to give you credit for it, guys. And I know that you're probably thinking, nice, I just got the points, and you will get the points. So guys, if you turned in anything, I will give you full credit for it. My side of this, that's wildly disappointing because one, I don't get to see your stuff, but two, I'm sending you this message that the quality of your work didn't matter. And I know some of you guys really poured effort into this, and now you're thinking, wait a second, I got the same credit that some idiot did that did a really half-hearted job. Guys, there's nothing I can do about it. I can't see your work. So I'm just going to give you all credit for it. And this is the last time we will ever turn anything in this class electronically. It just doesn't work. So we're not going to mess with that anymore. So with that said, guys, let's go down here and look at the bottom of the calendar. Let's make sure all of this makes sense to you, and we'll go on from there. So guys, this is the bottom of the calendar. This is the end of the month. Thank you. So guys, it goes like this. Today, Monday, we are going to cover the last of the new material for this unit. But guys, you're going to have your second investigation assigned today. It is completely different than the first one. I know that first one just felt like a ton of work. Guys, this is much more kinder and gentler. So today you'll have a little bit of homework and you'll have your your next investigation assigned. On Wednesday, we will do another lab. And then Friday, we will take the test over this unit, and that second investigation will be due. You guys good? Okay, so here's what we're going to do. I need you really quickly to reach in your notebooks, grab your changes labs, hand them to the aisle. Then, guys, grab something you can take notes with and on, and we're going to get started. Here we go. Gimme, gimme, gimme. Perfect. Thank you, sir. Thanks, Sam. Thanks. Lila, Lila, don't. Ah! Oh, what am I going to do? You guys all done? Is that all of them? All right. Okay, so we need a little bit of this. All right. Oh, cool. Got it. So, guys, the topic is up on the board, and this is actually our laundry list for today. You are going to learn about 3 topics. Each one of these is an extension of what you learned last time. And when we've gone over each of these 3, you'll have time to work on your homework. And even though it's a short day, my suspicion is you'll probably get it done. In addition to that, again, you're going to get your next investigation assignment. And you can be thinking about that a little bit as well at the end of the day. So again, guys, the date today is the 26th. The topic for your notes today is ions, isotopes, average atomic mass. We're going to pick those off one at a time. When we're done, we're done. You guys ready to roll? Okay. So, guys, you don't need to write down what I'm about to throw on the board, but I want to help you connect what you're going to learn to what you already know. So, guys, this ought to look really familiar to you, right? Yeah, it's kind of the homework we just graded. And if you remember when we graded this, we skipped grading the protons column and the electrons column. And guys, we got to make sure that you understand why. Why was it appropriate to skip those 2 columns? They're the same as the atomic number. So the atomic number always tells you the number of protons. And then, guys, why is the number of protons the same as the number of electrons? It makes the atom not have a charge. So keep that in mind, and now let me ask you another question. Guys, this atomic mass, you may as well just grab your periodic tables and look. Find helium element number 2. What is the atomic mass of helium, the small red number? Well, it's not. What does it actually say? 4.002. And guys, or is it 6? Oh, is it 6? Oh, gosh, 260. Holy buckets. Okay, so guys, the question then is this. How can those numbers be decimal numbers? Remember, the idea is the atomic mass tells you the number of protons and neutrons, and how can you have 26 thousandths of a proton? Well, obviously you can't, right? And so some people have said, well, maybe it's the mass of the electrons. And that is actually not it either. So guys, we're going to talk about why are those numbers not whole numbers. So here's then what we're going to do today. Thought number 1 is this. The atomic number equals the number of protons. The protons equals the number of electrons. But guys, what happens if these 2 numbers are not the same? And that's the first thing we're going to tackle. So the number of protons is always the atomic number. These are always equal. But what happens if these are not equal? And that's the first thing we're going to do. Then, guys, the next question that we're going to answer is this. Relating to atomic mass, why are these not whole numbers? And we'll talk about that. And then, guys, question number 3 is, how do we come up with these numbers? These average atomic masses, how do we actually calculate these numbers? I'm going to show you how to do the math, and then your investigation is going to be to figure out how we collect the data. Basically, the question is, how do we weigh atoms? Because that's what we're talking about doing, is weighing atoms, and your investigation is going to be about how we do that. Okay, so guys, again, number 1, what if these aren't the same? Number 2, why are these not whole numbers? Number 3, where on stinking earth did these numbers come from? Get the idea? Okay, here we go. Number one is this, ions. So guys, let me ask you a question. Why did the number of protons equal the number of electrons? What does that do to the atom? Makes it neutral, no charge. So what would be true if the protons and the electrons aren't the same? It's going to have a charge. Guys, that's what ions are. Ions are atoms with a charge. So guys, do this with me. Just sort of off to the right, draw yourself an atom. Oops. Hold on a second, guys. I need to grab my writing tools. Alright, so let's do this, and let's do this, and okay. Alright, oh, there we go. Okay, so guys, do this. Let's make this a carbon atom. So look on your periodic table, find carbon. It's in the upper right. What is the atomic number of carbon? 6. So what does that tell you about carbon? 6 protons. Now, the mass of carbon is 12. So what does that tell you about carbon relative to neutrons? 12 minus 6 is 6, so 6 neutrons, and then 6 electrons makes this no charge. So up until now, that's been a carbon atom for you. You guys all okay? Okay. Now, guys, what we're going to do is this. Well, I'll keep my pen. Now what we're going to do is we're going to give this carbon a negative charge. So say that we wanted to take this carbon atom and give it a negative charge. What could we do? Go ahead. Exactly. We can come along and we can do this, and instead of 6 electrons, we can add an electron, and now it's got 7 electrons. We've got one more electron than proton. That gives it a negative charge. You get the idea? Okay. So guys, there's a name for that, and that is what is called an anion. This is 2 hard syllables. It's not anion. This is an anion. So by definition, an anion is a negatively charged ion. So guys, how did we make that anion? We took carbon and we gave it a negative charge. What did we do to do that? How did we make carbon negative? What did we just do right here? Added an electron. So guys, when we form anions, we do that by adding electrons. So guys, when we think about anions, then we think about atoms that are electron rich. Okay, so now let's reset the scales. Let's put this back to 6. And now let's go in the other direction. So now, guys, let's take this carbon atom and let's make it carbon with a positive charge. So if we want to make this carbon with a positive charge, we can come along here, and instead of 6 protons, we can add an extra proton. Now we've got 7 protons, and this is carbon with a positive charge. Why not? What's that? Say it again. Now it's nitrogen. See guys, when we add protons to an atom, we are changing the charge, but we're also changing the identity of the element. So we can't do this way because this is not carbon with a positive charge. This is nitrogen with a positive charge. So let's get it back to 6 and talk about the other way we can do this, the right way. What can we do to make this carbon with a positive charge? Exactly, remove an electron. So if we come along like this, and if we take away an electron, now we've got carbon with a positive charge. So guys, bottom line is you never mess around with the protons, you only mess around with the electrons. And so these things are called cations. And guys, as you might expect, cations are positively charged ions that are formed by losing electrons, and these things are electron deficient. Bless you. So guys, how on earth are you going to remember that anions are negative and cations are positive? You got to know that. How are you going to keep them straight? Ready for a trick? What does the letter T look like in cation? Kind of like a plus sign. So if you can remember that the T in cation looks like a plus sign, you'll be able to remember that cations are positive and anions are negative. How you doing on the idea? You good? Okay, so now guys, let's do this. Let's give you a second to practice. So guys, write these both down. Actually, well, yeah, you can write them both down now and then we'll fiddle with them. So we're going to figure out what calcium looks like with a +2 charge. Notice how we write it. The +2 is superscripted to the right, and then we've got nitrogen with a -3 charge. Notice that the -3 is superscripted to the right. You guys good? Sort of caught up? Okay, so find calcium. Have you noticed this is kind of the hardest part of this stuff right now is finding the elements? Calcium's on the right-hand side. Is it 3 or 4 down and 1 over? Or I'm sorry, the left-hand side. 4 down, 3 down, 1 over. It's element number 20. So guys, if calcium is element number 20, what does that tell you for sure? 20 protons. If it ain't 20 protons, it ain't calcium. So now guys, let's figure out the neutrons. Again, you know that neutrons is the atomic mass minus the atomic number. Isn't the mass of calcium like 40.1? Is that right? So it 0.07. Okay, so it rounds down to 40. And so 40 minus 20, that tells us that this has got 20 neutrons. Okay, now let's talk electrons. Calcium should have 20 electrons. That's how many it has when it's stable. But if we make this calcium +2, what are we going to do? Are we going to add 2 electrons or remove 2 electrons? But hold on a second. This says +2. Why are you removing electrons if it says +2? Because the electrons are negative. And so if you want to give this a +2 charge, you've got to remove 2 electrons, and this then becomes 18 electrons. So guys, I know that that's a little counterintuitive. If it says +2, you subtract. But the reason, as Stephen mentioned, is because that electrons are negative. So if you wanted to have a +2 charge, take 2 away. Now we've got 2 more positives than negative +2 charge. You guys good? Questions? Go do nitrogen. Do this on your own. See if we can then do it together. If you don't have questions on this, we can trust that you understand ions, and we can move on. You guys good? So you found nitrogen, right? It's on the right-hand side. It's in the first horizontal row, sort of in the middle. It's element number 7. So guys, nitrogen is element number 7. It's got to be 7 protons or it ain't nitrogen. Now let's figure out neutrons. It has a mass of 14. 14 minus 7 is also 7. So now guys, we know that nitrogen wants 7 electrons. But to give it a -3 charge, do we add or subtract 3? Add 3, right? And that then gives it 10 electrons. Now guys, here's an interesting question. Look at neon, element number 10. How many electrons does neon have? If it's element number 10, how many electrons does neon have? 10. So does nitrogen with a -3 charge. So did we just turn nitrogen into neon? No, they have the same electron structure, but they are not the same atoms because the identity of the atom is determined by the protons and not the electrons. So neon with a -3 charge also has 10 electrons, but it doesn't become neon. It just has the electron structure of neon. You get the idea? Okay, so guys, big deep breath. How you guys doing on ions? Atoms with a charge, cations are positive, anions are negative, and you know how to form them. Good? All right, 1 for 1. Now guys, let's go on and let's talk about the next concept we need to cover, which are isotopes. So guys, I'm going to define it for you first, and then we're going to play with the concept. So guys, isotopes are atoms of the same element with different masses. So guys, I'm going to encourage you not to write this down. No, not this, but the thing that's coming up next. You want to write down the definition. All right. So guys, don't write this down. But we're going to fill this out together. So we're going to talk about the element carbon. So guys, if we're going to talk about the element carbon, the first thing we need is a sample of carbon. Many of you have one in your hand because guys, this is a sample of carbon. Do you guys understand that? That this is not pencil lead? What is this? It's graphite. And guys, graphite is pure carbon. See, they don't use pencil lead anymore because lead causes cancer, so you can no longer buy pencil lead unless you go to an art supply store where they will sell you lead still. Guys, this is pencil carbon, and carbon is graphite. And so guys, if this is carbon or graphite, what do all the atoms inside this pencil graphite have in common if they're all carbon? They have the same number of protons, and that would be 6. So guys, all of the atoms inside of our pencil all have 6 protons and they all have 6 electrons. Here's the thing that's interesting about all the carbon inside this pencil. It doesn't all weigh the same. Guys, it turns out that some of this carbon actually has 4 neutrons. And some of this carbon has got 6 neutrons. And some of this carbon has got 8 neutrons. So guys, how then are these atoms different? Well, how much does this one weigh? This guy here, 10. So this is called carbon 10. How much does this weigh? 12. This is called carbon 12. How much does that guy weigh? 14. This is carbon 14, and maybe some of you have heard of that because it's radioactive and we can use it to date things that are prehistoric by figuring out how much carbon 14 they contain. But guys, the trick is this. If you get a sample of carbon like is inside of all of our pencils, inside this sample of carbon, there is carbon that weighs 10 because it's got 4 neutrons, carbon that weighs 12 because it's got 6, and carbon that weighs 14 because it's got 8. So guys, all of those different types of carbon are inside this pencil. Now guys, look on your periodic table and find the mass of carbon. What is the mass of carbon? 12.011. So guys, with that in mind, that the mass of carbon is 12.011, I got 2 questions for you. First of all, which one of these 3 atoms is actually carbon? All of them. Guys, just because carbon 12 has a mass that is closer to what's on the periodic table does not mean that this is actually carbon and the rest of them are mutants. Guys, all of these are carbon. All of these exist. They react like carbon. They're all carbon. So then the question becomes this. If they are all carbon, then where on stinking earth did 12.011 come from? Exactly. Guys, it is a weighted average of all the different types of carbon that exist. So when we find out that carbon weighs 12.011, what they actually do is they take the graphite that's inside a pencil and they sort it into piles by weight. So they take all the atoms of carbon that weigh 10 and they put them in one pile, all the carbon atoms that weigh 12 in a pile, all the atoms that weigh 14, they put those in a pile, then they weigh them and they count them and they come up with the weighted average. Do you get the idea? How on earth do you weigh and sort and count atoms? Guys, remember, these are smaller than blueberries in the earth, right? A grapefruit atoms expand the atoms to the size of blueberries. The grapefruit becomes the size of the earth. How on stinking earth do we weigh and sort and count something as small as atoms? That's your investigation, and we'll talk more about that in a minute. But guys, for now, you've got to understand the idea that in samples of elements like carbon and lots of others, these atoms have lots of different masses. And so when we come up with these masses on the periodic table, they are the weighted averages of all these masses. Does that make sense? Okay, so what do we call each of these different types of carbon? We call them isotopes. So this is an isotope of carbon with a mass of 10, this is an isotope of carbon with a mass of 12, and this is an isotope of carbon with a mass of 14. They're all carbon, they're just different isotopes of carbon because they have different masses. You get the idea? Okay, so let's summarize. This stuff you do want to write down. So here's what you need to understand about isotopes. So guys, first of all this, how are isotopes different? Well, they differ due to differing numbers of neutrons. But guys, it's critical that you understand this next point. Sounded like you were comfortable with the idea that if there are 3 different isotopes of carbon, it's not like carbon-12 is carbon and the other 2 are like mutants. Guys, you got to understand there is no correct isotope for an element. All atoms of an element are isotopes of each other, and they all behave chemically exactly the same. How you guys doing? Y'all caught up? Did any of you guys print the notes in here? None of you? Oh, man. What? Oh, but you don't print the class notes? Have any of you ever printed the class notes? What'd you think? Does it help? Okay, you were probably still taking notes, though, which is great. All right. You guys caught up? Okay, so guys, please do not write what's going to come up down here. I want to give you another example of this idea that atoms, elements contain different isotopes of that element. But guys, I'm giving you this example because we're going to come back to it when we talk about average atomic masses. So guys, look at neon again, element number 10. From the fact that it's element number 10, we know it's got 10 protons. Now guys, what is the mass of neon? I don't even know it. 20.18-ish. So guys, again, where does that number 20.18 come from? And it is an average of all the different isotopes of neon. Well guys, these are the different isotopes of neon. Neon actually exists in 3 different isotopes. We've got neon 20, neon 21, and neon 22. Notice they all have 10 protons and they all have 10 electrons. The difference is that they have differing numbers of neutrons. So neon 20 has 10, neon 21 has 11, and as you would expect, neon 22 has 12. You good on the idea? All right. So guys, let's call time out for a second. Do you have questions on isotopes? Sure? Nope. You guys are good? Okay. Then guys, do this with me. Let's figure these out. So guys, we're going to look at carbon-14. I know we've already looked at it, but I wanted you to have something familiar. And then guys, we're going to look at oxygen-17. Given that you said you didn't have any questions, I'm guessing you can probably do these on your own. So guys, give them a swing. We'll go over them together. Then we're going to look at what this is going to look like in your homework. We'll do a couple together that'll look more like your homework. And then guys, we're going to answer that third question, where do these masses come from off the periodic table? Talk about your second investigation, and then you'll have time to get your homework done. You guys ready to go? So you found carbon on the periodic table. You probably didn't need to look because you know this is element number 6, and that means it's got 6 electrons. Now to give this thing a mass of 14, how many neutrons does it need? It needs 8. So guys, this is the trick. If you are given a mass, like in this case carbon-14, if you are given a mass, all that that's telling you is use the mass that's given, don't use the average off the periodic table. If you're not given any mass data, then you just use the average off the table. So guys, oxygen-17, in order to be oxygen, this is 8 and this is 8. Now, in order to give this oxygen atom the mass of 17, how many neutrons do we need? Well, we need 9. You guys okay on isotopes? You're good? Okay. So guys, this is what this is going to look like in homework. And I don't think you necessarily need to write this down, but this is what this is going to look like when you do this in your homework. And I'd like to at least step through this with you. When you get to doing the homework, if you find that you're stuck, you'll get through a lot of it today so you can ask questions. If you get home tonight and you're stuck, watch the screencast. But guys, it goes like this, and I would encourage you to follow along. And let me just tell you, guys, you're going to miss the detail. Do you guys want to write this down? I don't know. Tell you what, let's do this. Let's do the first 2 without you writing them down. Let's do the third one together and then skip the last one. I'm going to ask you to write the third one down though, because it contains everything you need to know. So let's do the first one together. So guys, this is obviously magnesium. But guys, you'll notice that magnesium has a charge. So do we put the charge in the name? And the answer is no. So this charge does not go in the name. It only goes in the abbreviation. So you may want to jot that down to yourself and remind yourself, charges don't go in the names. Now guys, magnesium is element number 12, and it's got a mass of 24. That's right off the table. So guys, if magnesium is element number 12, how many protons does it have? 12. How many neutrons does it have? 24 minus 12, that would be 12. Now, how many electrons should magnesium have? 12. But if we want to give it a +2 charge, do we add 2 or remove 2? And it's 10. You guys okay? Okay. Now guys, let's look at this next one. Lead 209. Guys, what does this number 209 tell you? The mass. So what that means then is do not look on the periodic table for the mass. We are going to use 209. So if you're given a mass, use it. If you're not, look it up on the table. But then guys, when you abbreviate this, you go lead and then you go 209. So the masses do go in the abbreviations. So no charges in the names, but masses do go in the abbreviations. So lead is element number 82. So that means it's got 82 protons and it's got 82 electrons. Now, how many neutrons does it have? Well, 209 minus 82, 127. Are we good? All right. Guys, I would really encourage you to write down the third one because this one is crazy. Let's see what you learned. So we've got aluminum. We know it's Al. It's element 13. We'll need that in a minute. But guys, this is alumin. Is it eum? I never remember. Yeah, aluminum, which means that the British pronounce it wrong because they call it aluminium. So we've got aluminum. And aluminum is abbreviated Al. So now let's start filling this out. So guys, Z is the atomic number for aluminum. That's 13. Now guys, check this out. What is the average mass on the periodic table for aluminum? 26 and change. Is it above 5? 26 point, it's like 9? 9. So it rounds up to 27. So guys, watch what that means. This is not the average mass. The average mass of aluminum is 27. This is 25. So that is not the average mass. That means that it goes here and it goes there. So anytime you have a mass other than the average mass, it goes in the name and it goes in the abbreviation. So now let's keep going. So this then tells us for sure 13 protons. Now guys, how many neutrons does aluminum 25 have? 12. 25 minus 13, that would be 12. Now, how many electrons does aluminum want? How many should it have? 13. What does it mean that it's only got 10? It's got a charge. It's got a charge of plus 3. So where does the plus 3 charge go? Right there. Does it go in the name? It does not. You got the idea? Guys, that's what you need to keep track of, and you'll see that in homework as well. So now let's call timeout again. We've got ions, we've got isotopes, we understand what they are. Now we understand how we handle them. You guys doing okay? All right, one more thing to go. Guys, the last question we need to ask and answer is where on earth did these masses come from on the periodic table? So we are going to talk about calculating average atomic masses. Guys, I'm going to encourage you to not take notes on this, okay, until the end where I show you how to do the math. So it goes like this. So guys, when we calculate average atomic masses, again, don't try to write this down. Here's the idea. See guys, there are lots of different isotopes for any element that is naturally occurring. Carbon's got 3, 10, 12, and 14. So in order to find the masses on the periodic table, we need to figure out the average. Now guys, in order to do this, and this explains why these numbers on the periodic table aren't whole numbers, to do this we need to know two things. We need to know the masses of the isotopes, and we also need to know how much of each isotope exists. Because if carbon contains 3 different isotopes, it's not 33% of each. There's more of some and less of another, so we need to know how much exists. So guys, go back to our sample of neon. So here's what we know. We know the masses. How much does this isotope of neon weigh? Well, it weighs 20. And guys, this one weighs 21, and this one weighs 22. So we know the masses of the isotopes. The thing we don't know is how much of them there are. But guys, this is actually the data. If you were to take a neon sign, a red glowing sign, and crack it open and sort all the atoms into piles, you would find out that neon is about 91% neon 20. It's about 0.25% neon 21, and it's about 9 1/3% neon 22. So guys, most of neon actually has 10 neutrons. A little bit of it has 11, and about 10% of it has 12. So where then does that number on the periodic table, 20 point whatever, come from? It's the average of all of these. So how do we find the average? You want to write this down. Guys, this is the equation. Average atomic mass is equal to the ratio sexy E times the quantity mass times percentage divided by 100. Do you guys know about sexy E? No. That's actually the mathematical term for that. It's called sexy E. Now this is, guys, is actually the Greek letter sigma. We actually translated it into the letter S. It's actually not an E at all. It eventually became our letter S. And as the letter S, it actually stands for the mathematical process sum, S-U-M, which means what? To add things together. So guys, this letter here, which is actually the Greek letter sigma, means to sum, which means to add it up. So functionally what this means is the average atomic mass is equal to the masses times the percentages, added all up and then divided by 100. Okay, so guys, the math looks like this. Let's look at our numbers. We've got 90% mass 20, 0.27% mass 21, 9.3% mass 22. So we've got a mass times a percent and a mass times a percent and a mass times a percent. And then we've just got to add them up. But guys, what are the units for these masses? 20 what? 21 what? You remember? AMUs. So make sure you label your number. So guys, write this down with me. It goes like this. Average atomic mass is equal to, and look at where we're getting our data. Our first mass, which is 20%, times our first percentage, which is 90.5. And by the way, guys, if you'd like, AMU can actually just be abbreviated U. That is the accepted abbreviation for AMU. So you can put U if you'd like. Then, guys, we've got our next mass, 21 times our next percentage, 0.27. And then we've got our last mass, 22, times our last percentage, 9.3. And then we divide that by 100. Now, guys, at this point, you are going to get really frustrated with your TI calculators. TI calculators, while they're wonderful tools, are horrible at orders of operations. In order to fix that, you're either going to have to type this entire thing in with parentheses, or do each of these multiplications individually, then add up the result and divide by 100. So guys, let's error check really quickly to make sure that this doesn't mess you up. So guys, without doing any math, join me at the board and answer this question. What type of answer would be a reasonable answer to this calculation? Where does your answer have to lie? You're finding an average mass, right? Where do averages have to be? Somewhere in the middle. So if you end up with an average mass below 20, you know it's not right. And if you end up with an average mass above 22, you know it's not right. So guys, you can always error check by making sure that your answer actually is between your high and low mass. So guys, go ahead and do the math. I know that you're now thinking about significant digits. Guys, those masses are understood to be perfect. You cannot have fractions of protons and neutrons, so those masses are perfect, which means that your significant digits are going to be determined by your percentages, which means you'll get 3 digits in your answer, and the answer is 20.2 atomic mass units. So guys, I'd love to sit down and help you with the math if you need. I mean, it's really, sort of, pretty straightforward math. I think if you're having a problem with it, it's probably somewhere in your calculator. That's how the math works. You okay? Okay. So guys, one last thing to talk about and we're done. As we said, we have an investigation that we need to talk about. So guys, let me introduce you to the idea. The question that you're going to answer in your investigation is where on stinking earth did these numbers come from? Imagine that you're handed a neon sign and somebody tells you, break open this neon sign, sort all of the atoms by weight, then count how many there are and come up with their relative abundances. Guys, that's obviously bordering on impossible, but we do it all the time. It's actually stuff that we can even do at sort of a secondary university. I mean, even like UVU and schools like that. And UVU is a great school, but they're not a research university. And guys, they have the machines to do this. They kind of look like a big dishwasher. They're really fascinating. But guys, the name of these things is what is called a mass spectrometer. And what you are going to do for your next investigation is you are going to figure out how a mass spectrometer works. You're going to do this individually. You will not be doing this in groups, and you're going to turn it in on Friday. So guys, here's the scoop. This is going to fit on one and only one sheet of paper. And this is your assignment. It says this: mass spectrometry is the process used to determine the relative mass and abundance of isotopes in a sample of an element. For this investigation, you are going to explain visually and verbally how these things work. So you're welcome to use whatever resources you want, but you've got to make sure that you cite your sources. So here's the requirement: one sheet of paper. Requirement number 2, on the front of this paper, you are going to write a 12-point double-spaced explanation of how this works. But guys, I don't want to hear any mumbo-jumbo that you found on Wikipedia. This is all in your words. Imagine that you're explaining this to a 9-year-old. It's very apparent, guys, when you're copying words off of websites that you have no clue what they mean. So get out, learn all you can, cite your sources, and then guys, imagine that your audience is a 10-year-old and explain to them the way a mass spectrometer works. So then guys, when you're done with that, and guys, please, I'm not looking for a full page. I think you could probably do this in 1/2 to 3/4 of a page, but write well. Well-formed paragraphs. I don't even need to say that. Then on the back of the page, guys, you are going to hand draw a representation of a sample passing through a mass spectrometer. You're going to find lots of artwork about how these work. I would be careful about just copying something, but invariably it's just going to be, it doesn't need to be like super artistic. I mean, it's probably going to be boxes and squares and lines and dots. But when you do this, you're also going to label the important parts of the device and then show the resulting separation that happens when isotopes pass through the detector. So guys, this will be due on Friday. Again, it's 1 per person. And I think you're going to find this fascinating. Here's the problem that you're going to run into is as you start researching this, you're going to find that a lot of the resources that you get into are really deep. You want to find things that are really superficial. A good place to start is Bozeman Science. If you're not familiar with Bozeman Science, this guy's a high school physics chemistry teacher up in Bozeman, Montana, that actually has put together a phenomenal website with all sorts of videos. Bozeman Science is a great place to start, although the first 5 minutes of the video is unnecessary, but the last 5 minutes are brilliant. So guys, that's due Friday. So here's what we got. Today you got homework. Wednesday we will grade that homework and do another lab. Friday you will turn in your investigations, and the lab that you did on Wednesday will not be due Friday. We will take the unit test on Friday, and you already have the study guide in your possession. Also on Wednesday I'll give you your test back. So questions? Okay, so guys, you've got the homework in front of you. You'll notice that it is double-sided. The front is a table that looks just like the table that we did last time, only this has got ions and isotopes on it. Then on the back, guys, there are 2 average atomic mass questions. We will grade these on Wednesday. Go get them.